Welcome to Designing an Azure Data Implementation. My name's Guy Hummel, and I'll be helping you with the data aspects of architecting an Azure solution. I'm a Microsoft Certified Azure Solutions Architect, and I'm the Azure Content Lead at Cloud Academy. If you have any questions, feel free to connect with me on LinkedIn and send me a message, or send an email to support@cloudacademy.com. This course is intended for people who want to become Azure Cloud Architects. To get the most from this course, you should have a general knowledge of IT architecture, especially databases. We'll start with an overview of Azure Storage, then we'll go over some data services that don't fit in the usual storage or database categories, such as Data Factory and HD Insight. Next, we'll look at relational databases, especially Azure SQL Database. After that, we'll go through Azure's NoSQL services, such as Azure Data Lake and Azure Redis Cache. Finally, we'll go into quite a bit of detail on Cosmos DB, Microsoft's global multi-model database. By the end of this course, you should be able to identify the most appropriate Azure services for various data-related needs, design an Azure SQL Database implementation for scalability, availability, and disaster recovery, and design an Azure Cosmos DB implementation for cost, performance, consistency, availability, and business continuity. We'd love to get your feedback on this course, so please give it a rating when you're finished. Now, if you're ready to learn how to get the most out of Azure's data services, then let's get started. If you need to store data but you don't need a full-blown database, then Azure Storage is the way to go. First, it's durable and highly available because it stores all data redundantly. Second, it's secure because all data is encrypted automatically, and you can set fine-grained access control to it. Third, it's scalable because you can always add more data without having to worry about provisioning hardware to hold it. There is a 500 terabyte limit, but if you need more than that, you can contact Azure support. Fourth, it's a managed service, so you don't have to worry about maintenance. And finally, it's accessible over the web. Although data is always stored redundantly, there are 4 different options depending on your needs. Note that not all of these options are available in every region or for every type of data. We'll go from cheapest and least redundant to most expensive and most redundant. Locally redundant storage is replicated across racks in the same data center. This means that if there's a disaster at that data center, your data could be lost. Although this is highly unlikely, you should only use locally redundant storage if you can easily reconstruct your data. Zone redundant storage is replicated across 3 zones within one region, so if an entire zone goes down, your data will still be available. Geo-redundant storage is replicated across 2 regions, so even if an entire region goes down, your data will still be available. However, in the case of a regional disaster, you'd have to wait for Microsoft to perform a geo failover before you could access your data in the secondary region. That's why you may want to consider using read-access geo-redundant storage. It's the same as geo-redundant storage, except that if there's a disaster in your primary region, then you can read your data from the secondary region immediately. You won't have write access though, so if you can't wait until Microsoft restores availability in the primary region, then you'll have to copy your data to yet another region and point your applications to the new location. You can copy data to and from Azure Storage using the AZ Copy utility, Azure PowerShell, or the Azure Storage SDK, which is available for a variety of programming languages. Azure Storage supports 4 types of data: blobs, files, queues, and tables. Blob stands for binary large object, but really a blob is just a file. So why is there a distinction between blob storage and file storage? The difference is in how they're organized. Blobs aren't really organized at all. Sure, you can use slashes in their names, which makes it look like they have a folder structure, but they're not actually stored that way. File storage, on the other hand, has the sort of hierarchical structure you'd expect in a file system. In fact, it's SMB compliant, so you can use it as a file share. This makes it easy to move an on-premises file server to Azure. Even better, you can make this file share globally accessible over the web if you want. To do that, users need a shared access signature token, which allows access to particular data for a specific amount of time. You might be tempted to use file storage instead of blob storage, even when you don't need an SMB compliant file share. But bear in mind that it's significantly more expensive than blob storage. If you just need a place to put files, whether they're documents or videos or logs or anything else, then you should use blob storage, which is by far the cheapest of all the storage types. There are options for making blob storage even cheaper too. You can choose from 3 storage tiers: hot, cool, and archive. Hot storage is the tier you'll probably use the most often. It's intended for data that gets accessed frequently. If you have data that doesn't get accessed frequently, then you should consider the cool storage tier. It's optimized for data that still needs to be retrieved immediately when requested, even though it doesn't get accessed very often. An example would be a video file that people rarely watch. The cool tier has a much lower storage cost, but a much higher cost for reads and writes. The data also needs to be in the cool tier for at least 30 days. If you have data that will almost never be accessed, and you can live with it taking up to 15 hours to access when you do need it, then the archive tier is a way to save lots of money. It's 5 times cheaper than the cool tier for storage costs, but it's dramatically more expensive for read operations. The data also needs to reside in the archive tier for at least 180 days. You can move data between the tiers anytime you want. But if you do it before the minimum duration for the cool and archive tiers, then you'll be charged an early deletion fee. For example, if you put your data in the archive tier and then move it back to the cool tier 90 days later, you'll be charged half of the early deletion fee, since you moved the data when there was still half of the 180-day minimum left to go. Queue storage is a very different option. It's intended for passing messages between applications. One application pushes messages onto the queue, and another application asynchronously retrieves those messages from the queue, one at a time, and processes them. We'll talk more about messaging systems in another course. I find table storage to be the most surprising type of Azure storage. It's a NoSQL data store with storage costs that are about the same as file storage, and with way cheaper transaction costs. I think Microsoft realized what a good deal this is too, because they now have a premium version of table storage that's part of their Cosmos DB service. We'll talk about both versions of table storage again in other courses. I should also mention that there's another type of Azure storage. Disk storage is what's used for the disks that are attached to virtual machines, but we don't need to go into the details here. Microsoft is very good about providing options for hybrid solutions where you can use both Azure and your existing on-premises infrastructure. Store Simple is Microsoft's hybrid offering in the storage area. It's a virtual array that you install at your own site, and it's primarily used to do backup, recovery, and storage tiering. Of course, you don't need to use Store Simple to copy or move your data to the Azure cloud, but it makes the process so much easier. For example, here's how storage tiering works. You provision enough local storage for your current needs, and then as you need more capacity, it moves your infrequently accessed data to the cloud. It even deduplicates and compresses the data before sending it, so your Azure storage costs are as low as possible. This all happens seamlessly in the background. If you have a disaster locally and need to recover data from the cloud, Store Simple restores the metadata first and then restores the data itself as needed. That way you can get up and running again very quickly. And that's it for Azure Storage. In this lesson, we'll cover services that don't fall into the usual categories of basic storage, transactional databases, or NoSQL data stores. These services help you work with data in other ways, such as finding, transforming, and analyzing it. First up is Azure Data Catalog. Organizations typically have so much data in so many different places that it's hard to find what you're looking for. The purpose of Data Catalog is to act as an index to all of those data sources, so you can discover them. Of course, in order for this to work, your employees need to register their data sources in the catalog. The data itself always stays where it is, but its location and the metadata about it get added to the catalog. The metadata includes things like column names and data types. Users can also add additional information about a data source, such as a description or some tags. Once various data sources are registered, people can search the catalog to find what they're looking for. They still need to open the data using another tool though, since this is just a catalog. Another way to deal with pockets of data is to collect it in either a data lake or a data warehouse. These serve two different but related needs. Azure SQL Data Warehouse gives us a clue about its purpose in the name itself. It's intended for SQL queries. That also implies that it stores data in structured relational tables. If you have raw data that's not in a nicely structured format, then you'll probably need to process it before you store it in SQL Data Warehouse. Azure Data Lake Storage, on the other hand, will store any kind of data, whether it's structured or not. For example, you could store everything from documents to images to social media streams. Data warehouses are generally used for business reporting, while data lakes are more often used for data analytics and exploration. In fact, one common setup is to process data in the data lake and then export it to the data warehouse. The two services are designed to work with different types of software too. SQL Data Warehouse is built on SQL Server, so it works well with that ecosystem of software. Data Lake Storage, in contrast, is built to work with Hadoop. That's because Hadoop excels at processing unstructured data. One final difference is that SQL Data Warehouse is certified for compliance with over 20 standards, including HIPAA. Data Lake Storage does not have regulatory compliance. This is another reason why it makes sense to use SQL Data Warehouse to serve data to a wider audience. Both services are designed for performing massive queries at high speed. With SQL Data Warehouse, you write queries using T-SQL. With Azure Data Lake Storage, you can run queries using Hadoop, but you'll get higher performance by using Azure Data Lake Analytics. It's a pay-as-you-go service that lets you write queries using USQL, which is a combination of SQL and C#. If you do want to use Hadoop to process your data, then you can use Azure HD Insight. It supports a wide variety of open-source big data frameworks, including Hadoop, Spark, Hive, Storm, and many others. You don't even have to use Data Lake Storage if you don't want to, because it also supports Azure Storage. One difference between Data Lake Analytics and HD Insight is ease of use. With HD Insight, you need to spin up a cluster to run a processing job. So if you need to run jobs quite often, you can leave a cluster running all the time, which could be expensive. Or you could spin clusters up and down as you need them, which would be kind of a pain. One way to make HD Insight work more like Data Lake Analytics is to use yet another service, Azure Data Factory. It lets you create workflows to automate data movement and data transformation. One of its many capabilities is spinning up and down HD Insight clusters as needed, but it can do far more than that. With Data Factory, you can create data processing pipelines. For example, a pipeline could copy data from SQL Server to Data Lake Storage, run a Spark job on the data using an HD Insight cluster, and store the results in SQL Data Warehouse, all without any human intervention. It can even automate Data Lake Analytics queries and machine learning jobs. It's a great data processing tool. One more data analytics tool is Azure Analysis Services. It lets you create data models that make sense of existing data. One of the problems with the multitude of data in organizations is that it can be hard to understand how all of that data relates to the real world. Using a data model is easier than working with the raw data. Analysis Services also makes browsing large amounts of data faster because it uses in-memory caching. However, end users don't browse directly through Analysis Services. Instead, they use one of the supported client tools, such as Power BI, Tableau, or Excel. And that's it for Azure Data Services. SQL Server has been one of the most popular relational databases for a very long time, so it's not surprising that Microsoft has made it available as a managed Azure service as well. But Azure supports other relational databases too. Microsoft offers a surprisingly high level of support for the most popular open-source relational databases, MySQL and PostgreSQL. If you have existing databases running on either of these systems, and you want to migrate them to Azure, then you should use Azure Database for MySQL and Azure Database for PostgreSQL. These are managed services that give you lots of extra goodies, including high availability, backups, security, and compliance. There's even a free service that can migrate your existing databases to Azure with minimal downtime. The managed service price is quite reasonable, so there isn't much reason to run these databases directly on virtual machines because you'd have to manage them yourself. Okay, back to SQL Server. The most obvious way to migrate your SQL Server databases is to use Azure SQL Database. However, if you're currently running SQL Server 2016 or higher, there's another option you may want to consider. It's called SQL Server Stretch Database. It's very similar to StoreSimple, except it's for database records instead of files. It migrates cold table rows, that is, infrequently queried rows, to Azure. This happens in the background automatically. And you can still query the data that is migrated to Azure too. The only difference is that the query will take a bit longer than usual. Stretch Database is a good solution if your on-site data keeps growing. First, instead of buying more storage to handle the growth, you can just migrate your cold data to Azure, which is usually cheaper and easier. Second, as your data grows, backups take longer to run. Eventually, your backups may not be able to run within your backup window. By migrating your cold data to the cloud, your on-site backups run faster, and your cloud backups happen automatically. Of course, if your users almost never need to query your cold data, then it would be cheaper to store it offline than in Azure. But in most organizations, people do need to query cold data occasionally, and it would be a pain to bring that data back online every time it's needed. So storing it in Azure is usually a better choice. Microsoft even provides a tool called Data Migration Assistant that makes recommendations on many aspects of data migration, including Stretch Database. It tells you which databases and tables would be good candidates for Stretch Database. It also tells you about potential blocking issues, because there are a number of constraints that can prevent data from being migrated, such as tables that have more than 1,023 columns. If you'd rather bite the bullet and just move an entire database to Azure, then there are two ways to do it. Ideally, you would move it to Azure SQL Database, which is a managed version of SQL Server. One of the big advantages is that you wouldn't need to worry about maintenance anymore, because Microsoft takes care of all patches and updates, as well as all of the underlying infrastructure. It isn't always possible to move an existing SQL Server database to Azure SQL Database, though, because they're not 100% compatible with each other. In the same data migration assistant that I mentioned earlier, it tells you what re-engineering, if any, would be required to move a database to the SQL Database service. If the re-engineering effort would be too great, then one option is to move the database to a SQL Server instance running on a virtual machine in Azure. The disadvantage is that you would have to take care of maintaining the instance. So Microsoft has an offering called SQL Database Managed Instance that gives you the best of both worlds. It's nearly 100% compatible with SQL Server, but it's managed, so you don't have to worry about maintenance. Microsoft provides a surprising number of options for running and scaling SQL Database. First, there are 3 service tiers: General Purpose, Hyperscale, and Business Critical. These service tiers have very different architectures from each other. The General Purpose tier is the default. If you don't have any special size, performance, or availability requirements, then this is the best and least expensive choice. Despite its budget pricing, it still offers a low 5 to 10 millisecond latency and 99.99% availability. One of its limitations, though, is database size. It can't hold more than 4 terabytes, or 8 terabytes for a managed instance. If you need more space than that, then the Hyperscale tier is the way to go. It supports databases of up to 100 terabytes. Not only that, but it can scale its compute resources up and down very quickly. It also provides instant backups and fast database restores. If you need lightning-fast performance, then the Business Critical tier is the best choice. It provides 1 to 2 millisecond latency. It does this by using local SSD storage. Normally, it's risky to use local storage because that makes it more difficult to provide high availability, but Microsoft has solved that problem by using a 4-node cluster. Of course, that makes it more expensive too. You can even get higher availability than the General Purpose tier by choosing the Zone Redundant option, which spreads the 3 read replicas in the cluster across the availability zones in a region. This gives it a 99.995% availability. You can't scale a database beyond 4 terabytes though, so if you have a database that's bigger than that, then you'll still need to use the Hyperscale tier and lose the advantages of the Business Critical tier. Okay, we've gone through the service tiers, but there are lots of other options as well. The next decision to make is which resource type to use. The choices are Single Database, Elastic Pool, and Managed Instance. A single database is pretty self-explanatory. If you only need one database, then this is usually a good option. The difference between the single database model and the Elastic Pool model is that an Elastic Pool can contain multiple databases that share resources with each other. This model works well if your databases are not all busy at the same time. For example, suppose that you have 5 databases and they all experience spikes in demand occasionally, but they don't all experience these spikes at the same time. Putting them in a pool of shared resources would be much cheaper than provisioning 5 single databases, because you'd have to provision enough resources for each of the single databases to handle spikes, even though they wouldn't need that capacity most of the time. With Elastic Pools, you can also set minimum and maximum resources for each database to ensure that one database doesn't consume all of the resources in the pool. As I mentioned earlier, a managed instance has the highest compatibility with SQL Server. If you need to migrate an existing SQL Server database to Azure, then Managed Instance is the easiest way to do it. One disadvantage, though, is that Managed Instance doesn't work with the Hyperscale tier, so it doesn't support databases larger than 8 terabytes. I should also mention that Elastic Pools don't work with the Hyperscale tier either. Alright, there's yet another option you need to know: purchasing models. There are 2 different ways you can pay for your databases: DTUs or vCores. Database Transaction Units, or DTUs, used to be the only option. A DTU is a balanced bundle of compute, storage, and I/O resources. The problem with this model is that it's not very flexible. For example, if you have a workload that needs a lot of storage but not much compute power, then you'll be paying for a lot of excess compute power that you don't need. Microsoft introduced the Virtual Core, or vCore model, to provide more flexibility, and it's now the recommended purchasing model. It allows you to select the number of virtual CPU cores separately from the maximum storage space size. It also lets you specify the hardware generation, which includes options for memory-optimized and compute-optimized configurations. And we're not done yet, because there's another purchasing option within the vCore model. You can choose either provisioned or serverless. With the provisioned model, your SQL database instance gets provisioned with the exact resources you requested, and you get charged for the database as long as it's running. With the serverless purchasing model, you specify the minimum and maximum number of vCores, and it will auto-scale based on workload demand. Then you can configure it so that if there's no activity for a period of time, it will pause the database and you won't be charged for any compute resources until new activity causes the compute resources to come back up. This sounds great, doesn't it? So why wouldn't you always choose the serverless option? Well, the cost per vCore is higher for serverless than it is for provisioned. So if your database was active most of the time, then the serverless option would be more expensive. By the way, even if you don't choose the serverless option, you can still scale your database manually when you need to. You can just edit the database's configuration and change the number of vCores, or DTUs if you're using that model. There will be a brief loss of connectivity while it switches over to the new resources, but it generally takes less than 4 seconds, so it shouldn't be very noticeable. Regardless of which service tier you choose, high availability within a region is handled automatically. SQL Database provides HA through a technology similar to always-on availability groups in SQL Server. The good news is that you don't have to do anything, even if there's a failure, because failover is automatic too. It may take up to 30 seconds to recover, but that should be acceptable in most cases. To protect against regional failures, you need to configure active geo-replication. This lets you create up to 4 read replicas in different regions. If the primary database becomes unavailable, then you, or your application, can fail over to one of the secondary databases. That secondary then becomes the new primary. To make this work, you need to ensure that your secondaries have user authentication configured in the same way as the primary. One way to do this is to use Azure Active Directory, so you don't need to manage credentials manually on your databases. You should also use the same firewall rules for secondaries as you do for your primary. One way to do this is to use database-level firewall rules, which are replicated with the database. Active geo-replication also has the side benefit that you can use the secondary databases to make queries faster for users in other regions. This is possible because the secondaries are read replicas, so as long as a user doesn't need to write to the database, they can connect to the nearest secondary instead of the primary. If you're using a managed instance, then disaster recovery is handled by auto failover groups, which is a layer on top of active geo-replication. Auto failover groups allow you to fail over multiple databases at the same time, which is a really nice feature. Even with high availability, backups are still important, so you can recover from cases of accidental corruption or deletion. Luckily, SQL Database automatically takes care of backups too. It saves them in read-access geo-redundant storage to protect against regional failures. Transaction log backups happen about every 5 or 10 minutes, so you won't lose much data if you do a point-in-time recovery. Backups are saved for 7 days by default, but you can increase the retention period up to 35 days. If you need to save them for longer than that, then you can configure a long-term backup retention policy for each database. You can keep backups for up to 10 years. Normally, you would restore data to the same server where it was originally located, but if you need to restore a database to a different server, then you can use GeoRestore. As the name implies, this is usually used to restore a database to another geographic region. If you're not using active geo-replication, then this is the way to fail over to another region. It typically takes about 12 hours though, so it's not a good solution for mission-critical applications. It can also result in the loss of up to an hour's worth of data, since it can take up to an hour for the backup copy in the primary region to be replicated to the secondary region. If the primary region goes down, then the secondary region may not have the latest backup. And that's it for relational database storage. Relational databases are great for online transaction processing, but the rise of big data has led to the need for bigger databases. NoSQL data stores are able to scale better because they satisfy fewer requirements than relational databases. Considering their name, it's not surprising that one requirement they don't fulfill is support for SQL queries. Azure offers a variety of NoSQL data stores, some of which are intended for very specialized purposes. We'll start with the more general purpose options. Azure Table Storage is a key attribute store, so it's intended for simple but structured data. For example, you could use it for address books or user profiles. It has a schemaless design, so the structure of your data can change without any trouble. It also automatically indexes the records, so queries are fast, although it doesn't create secondary indexes, so some queries could be slower. If you need secondary indexes or global distribution, then you can use the premium version that's part of Cosmos DB. If you don't need those features, then the basic version of table storage is a great choice, because it's an extremely cheap NoSQL data store that's easy to use. If you need more sophisticated features like complex joins, foreign keys, or stored procedures, then you should use a relational database instead. Azure Redis Cache is another general-purpose data store, but it's used under specific conditions. It's intended to speed up data retrieval in applications. It's a managed service for Redis, which is an open-source in-memory database. Since its data resides in memory, it's very fast, which is why it's used as a cache. It's even simpler than Azure Table Storage, because it just stores key value pairs. Azure Redis Cache is offered in 3 tiers. Basic doesn't have an SLA, so it should only be used for testing and development. The standard tier provides a replicated high-availability cache. The premium tier has better performance and can handle bigger workloads, disaster recovery, and other advanced features. Azure Data Lake Storage is different from table storage and Redis because it's not a key value store. It's intended to hold large quantities of any kind of data. It's essentially a data warehouse for unstructured data, and its main purpose is data analytics. Azure Search is a very specialized database. It creates an index of text data so your users can easily run searches on it. You can then embed search functionality into your web, mobile, and enterprise applications. Azure Search also provides a wide variety of features, such as search suggestions, language analyzers, and fuzzy searches. Time Series Insights, or TSI, is another highly specialized database. It collects timestamp data, such as data from IoT devices. Since this is a very common use case, TSI integrates with Azure IoT Hub and Azure Event Hubs. Once the data resides in TSI, you can run queries on billions of events and get a response in seconds. You can run these queries either interactively or from your applications. When you run queries interactively using TSI Explorer, you can see visualizations of the data. Azure has another NoSQL storage solution, Cosmos DB, but it's such a big topic that it'll take up a whole lesson. So if you're ready, then go to the next video. Cosmos DB is a pretty amazing database service. It used to be called Document DB, but Microsoft added so much new functionality to it that they had to rename it. Cosmos DB is such an unusual database service that it can take a while to understand it. I'll try to sum it up as briefly as I can. Cosmos DB's 2 most important features are that it's global and it's multi-model. Not only is it extremely easy to replicate a Cosmos DB database to multiple regions around the world, but Microsoft even provides service level agreements for latency, which isn't something you can get with normal database services. The multi-model feature may be even more innovative. Cosmos DB supports many different types of data models, including document, key value, graph, and wide column. It isn't the only database system that supports multiple models, but it's the first to be offered as a global cloud service. As I mentioned in the NoSQL lesson, Azure Table Storage now has a premium offering as part of Cosmos DB. It's accessed using the Table API. It's still a key attribute store, but it offers these additional features: global distribution, dedicated throughput worldwide, single-digit millisecond latencies at the 99th percentile, guaranteed high availability, and automatic secondary indexing. These features are not unique to the Table API. They're inherent capabilities of all Cosmos DB data models. Now let's look at the document data model. It's very similar to the key value model, but it provides richer querying capabilities. At the moment, Cosmos DB supports 2 different options for document databases: the MongoDB API and the SQL API. MongoDB is currently the most popular document database, and it's open source. It stores data in a JSON-like format, without a schema. With the MongoDB API, you can take applications that were written to work with a MongoDB database and point them to a Cosmos DB database instead. In many cases, you only need to change a connection string to make this work. Cosmos DB's second document database offering is the SQL API. This used to be called the Document DB API. The new name is actually kind of confusing, because a document database is technically a NoSQL database. So isn't it a contradiction to call it the SQL API? Well, it's called that because it lets you use a SQL-like language to query JSON documents, which is how Cosmos DB stores the data. Since SQL was designed to work with relational database tables, Microsoft couldn't just use SQL as is to query JSON documents, so it's not standard SQL. Furthermore, Microsoft incorporated JavaScript's programming model in their query language, so it's even more different from SQL than you would expect. Despite all of this, the SQL API still looks very similar to standard SQL, which makes it easier for people with SQL experience to use than the MongoDB API. Graph databases are more complex than document databases because they also store information about relationships between entities. For example, 2 people may be connected to each other on LinkedIn or Facebook. A graph database stores this relationship data separately from the user entities. Graphs are a great way to model real-world relationships, but you can still find ways to model them using other types of databases. Where graph databases really shine is with applications that need to traverse a graph from one entity to another, with other entities in between, such as a friend of a friend. Graph databases can perform these operations orders of magnitude faster than other types of databases. Some examples of application types that can benefit from graph databases are social networking, content management, geospatial, and product recommendations. The last data model supported by Cosmos DB is the wide column model. This is the model used by the Apache Cassandra database system. Cosmos DB provides the Cassandra API for applications that are written to use a Cassandra database. Yet another unusual feature of Cosmos DB is that you can choose from 5 different consistency levels. When you build a database system that's distributed across different locations, as is the case with Cosmos DB, you face the problem of how to keep all of the locations in sync. If data is written in one location, it has to be replicated to all of the other locations as well. But what if a read request comes in at one of the other locations immediately after the data was written at the first location? Since the replication wouldn't have happened yet, the read request wouldn't return the new data. But a read request against the first location would return the new data, so that would be inconsistent. This consistency problem is why relational databases usually have only one location. This makes it hard to scale relational databases and is the biggest reason why NoSQL databases became popular. There are many different ways to handle the consistency problem, and Cosmos DB supports 5 of them. Strong consistency guarantees that a read operation will return the most recent version of an item. This is the type of consistency that relational databases have. For a distributed database to achieve strong consistency, it has to ensure that each write operation has been propagated to all of the replicas before the operation is considered complete. There's an obvious problem with this approach. It's very slow, especially if the database is distributed over a wide geographic region. So how can Cosmos DB provide strong consistency for a global database? Well, it can't. If you choose strong consistency, then the database can only be in one region. At the other end of the spectrum is eventual consistency. The only guarantee made by this approach is that if no new writes are made to an item, then eventually all of the replicas will have the same value for that item. This is a very weak guarantee, because not only could a request return an old value, but it could return a value older than the one that you retrieved previously. This could happen if your second request connected to a replica that hadn't been updated yet. This is the level of consistency typically offered by NoSQL databases. It has the lowest latency, but the worst consistency. Cosmos DB offers 3 other consistency levels that are in between these two extremes. As you add more consistency, both the latency and the cost generally go up. Consistent prefix is the same as eventual consistency, except that it guarantees that read operations will never see out-of-order writes. That is, reads can still return older values, but never out of order. Session consistency guarantees consistency for each client session. So a client will never see data older than what it has written during a session. This is relatively easy to provide because the system doesn't have to worry about conflicts between multiple clients. It just needs to keep things consistent for an individual client. This approach offers the lowest latency reads and writes. It's also by far the most popular consistency level chosen by Cosmos DB customers. Bounded staleness guarantees that reads may lag behind writes by a limited amount of time. This costs as much as strong consistency, but it allows you to distribute your database across regions and has lower latency. This is the second most popular consistency level chosen by customers. Believe it or not, Cosmos DB allows you to specify a different consistency level on each request, although most customers don't do that. It also provides an SLA on both consistency and latency. Cosmos DB's pricing model is based on request units, or RUs. All API requests have a number of RUs assigned to them, based on the resources required to fulfill that request. For example, a complex SQL query would require more RUs than reading a single key value pair. Writes take more resources to execute than reads do, so they're 5 times more expensive. You need to tell Cosmos DB how many RUs per second to provision. This throughput capacity is applied to each region associated with your database account. You have to pay for this amount of capacity regardless of how much you actually use, but you can increase or decrease the RUs per second at any time. The number of RUs required to fulfill a request depends on many factors, including item size, number of properties in an item, consistency level, number of properties indexed, document indexing, query complexity, and script usage, that is, stored procedures and triggers. To estimate the number of RUs per second you'll need, you can use the request unit calculator. But it would probably be easier to run a few typical operations and see how many RUs they required. You can get that number from either the header in the response to your request, or from the Cosmos DB Data Explorer in the Azure portal. Then multiply that by the number of operations you expect to run per second. If your application exceeds the number of RUs per second that you reserved, Then your requests will be rate limited until the rate drops below the amount you reserved. On the plus side, Microsoft provides an SLA on the throughput level you reserve. Cosmos DB also provides an SLA on availability. It guarantees 99.99% availability for both single-region and multi-region databases. It also provides a 99.999% read availability SLA on multi-region databases. It can provide such strong HA guarantees because of its highly redundant architecture. Not only is the database replicated across regions, but it's also replicated within each region. In the unlikely event of a regional failure, Azure will automatically fail over your Cosmos DB databases to another region. You can make this process more efficient if you set a preferred regions list for each region. For example, if the West US region goes down, and your preferred regions list for that region has North Europe as the next region on the list, then that's where Azure will fail over to. When the region comes back online, Azure will automatically perform a recovery and bring the database back online in that region. You can also test how your application will respond to an outage by performing a manual failover. Cosmos DB automatically backs up your databases too. It takes snapshots every 4 hours and stores them in geo-redundant blob storage. Only the last 2 snapshots are retained. If you delete a database or a container within that database, then the snapshot will be retained for 30 days. If this backup schedule isn't sufficient for your needs, then you can schedule additional backups using the Cosmos DB data migration tool. If you accidentally delete a database or a container, then you have to submit a ticket with Azure support to restore it from the latest backup. If you have a data corruption issue, then you should delete the corrupted container as soon as possible. Otherwise, your backups will be overwritten with corrupted data. Then you can submit a support ticket to get it restored. Now I'm going to go over a few specific capabilities of the SQL API. Since it used to be the only supported API back when the service was called DocumentDB, it's the most mature. As I mentioned earlier, one of the great features of Cosmos DB is automatic indexing. However, there may be times when you'll want to customize the indexing. For example, you could reduce your costs by eliminating some of the indexes, or you could make document updates faster by not indexing them immediately. You can make these changes by setting an indexing policy on a collection. A collection is a group of documents. When you override the default indexing policy, you can do things like exclude specific documents or JSON properties. You can also configure the index update mode. There are 3 options for that: consistent, lazy, and none. The update mode is usually set to consistent, which means that the index gets updated when a document gets updated. If the update mode is set to lazy, then the index gets updated when the collection's throughput capacity isn't being maxed out by user requests. In other words, the index is often out of date and has eventual consistency, regardless of the consistency level for the document updates. The final update mode is none, which just means that the collection won't have an index. You can also make some of your queries more efficient by customizing the data type of an index. For example, suppose you're storing timestamped IoT data, and you often need to run queries on things like the average temperature reading for the previous day. To do this, you need to do a range query, and to make the query efficient, you need to create a range index. This is easy to do by setting a custom indexing policy. Another type of data that needs special indexing is geospatial data. The SQL API supports the GeoJSON specification. You can use GeoJSON point to represent the longitude and latitude of a location, such as a building, or GeoJSON line string to represent 2 or more points connected by line segments, such as a river, or GeoJSON polygon to represent a closed area, such as a lake. If you have geospatial data and you want to, for example, search for all of the houses within a 10-mile radius of a city center, then you'll need to set a custom indexing policy for geospatial data. And that's it for Cosmos DB. I hope you enjoyed learning about Azure's data services. Let's do a quick review of what you learned. Azure Storage has 4 different redundancy options. Locally redundant storage is replicated across racks in the same data center. Zone redundant storage is replicated across 3 zones within 1 region. Geo-redundant storage is replicated across 2 regions. Read-access geo-redundant storage is the same as geo-redundant storage, except that if there's a disaster in your primary region, then you can read your data from the secondary region immediately. Azure Storage supports 5 types of data: blobs, files, queues, tables, and disks. Blob storage holds data objects. You can choose from 3 storage tiers. Hot storage is for data that gets accessed frequently. Cool storage is for data that doesn't get accessed more than once every 30 days and that needs to be retrieved immediately when requested. Archive storage is for data that doesn't get accessed more than once every 180 days and that can take up to 15 hours to access when you need it. File storage is SMB compliant, so you can use it as a file share. Queue storage is for passing messages between applications. Table storage is a very simple and inexpensive NoSQL data store. Disk storage is for the disks that are attached to virtual machines. Store Simple is a virtual array that you install at your own site. It moves your infrequently used data to the cloud and lets you access that data seamlessly when you need it. Azure Data Catalog is an index to all of an organization's data. Each data source has to be manually registered in the catalog. Azure SQL Data Warehouse is a repository for structured relational data. It's used primarily for business reporting, and it works with the SQL Server ecosystem. Azure Data Lake Analytics lets you run NoSQL queries on Azure Data Lake Storage. You can also run queries on Data Lake Storage using Hadoop. The easiest way to run Hadoop is with the HD Insight service. With Azure Data Factory, you can create data processing pipelines. This lets you automate data movement and transformation. Azure Analysis Services lets you create data models to make sense of existing data. It sits between databases and business intelligence clients, such as Power BI. Azure Database for MySQL and Azure Database for PostgreSQL are managed services that provide high availability, backups, security, and compliance for MySQL and PostgreSQL. SQL Server Stretch Database migrates cold table rows to Azure, but still lets you query them. This saves you money and helps your backups run faster. Azure SQL Database is the preferred option for moving from SQL Server to Azure, but it's not 100% compatible with SQL Server, so there may be some re-engineering required. It offers 3 service tiers. Basic is for databases with less than 2 GB of data, Standard can hold up to 1 TB, and Premium can hold up to 4 TB. Premium offers the fastest I/O and support for in-memory processing. Standard and Premium offer a number of different performance levels measured in DTUs, which stands for Database Transaction Units. A DTU represents a bundle of compute, storage, and I/O resources. You also need to choose between the single database model and the elastic pool model. An elastic pool can contain multiple databases that share resources with each other. This model works well if the usage levels of your various databases are unpredictable. SQL Database is highly available within a region automatically. To make it highly available across regions, you need to configure active geo-replication. This lets you create up to 4 read replicas in different regions. SQL Database takes care of backups automatically too, but it even protects against regional failures out of the box. Transaction log backups happen about every 5 or 10 minutes. GeoRestore lets you restore a database to another geographic region from where it was backed up. Azure Table Storage is a key attribute store. It's schemaless and it automatically creates a primary index. Azure Redis Cache is a simple key value store. It runs in memory, which is why it's used as a cache. Azure Data Lake Storage is a NoSQL repository for all kinds of data. Azure Search creates an index of text data so your users can run searches. Time Series Insights collects timestamp data, such as data from IoT devices, and lets you run queries on it. Cosmos DB is globally distributed and it provides SLAs for latency, throughput, consistency, and availability. It has APIs to support various data models including table storage, MongoDB, SQL, Graph, and Cassandra. It offers 5 data consistency levels. Strong consistency guarantees completely consistent reads, but it's only available for single region databases. Bounded staleness guarantees that reads may lag behind writes by a limited amount of time. Session consistency guarantees consistency for each client session. Consistent prefix guarantees that read operations will never see out-of-order writes. Eventual consistency guarantees that if no new writes are made to an item, then eventually all of the replicas will have the same value for that item. You need to tell Cosmos DB how many RUs per second to provision. This throughput capacity is applied to each region associated with your database account. Cosmos DB guarantees 99.99% availability for both single region and multi-region databases. It also provides a 99.999% read availability SLA on multi-region databases. To make the automatic failover process more efficient, set a preferred regions list for each region. Cosmos DB automatically takes snapshots of your databases every 4 hours. Only the last 2 snapshots are retained. You can change the indexing behavior on a Cosmos DB collection by configuring a custom indexing policy. The 3 options for the index update mode are consistent, lazy, and none. Now you know how to identify the most appropriate Azure services for various data-related needs, design an Azure SQL Database implementation for scalability, availability, and disaster recovery, and design an Azure Cosmos DB implementation for cost, performance, consistency, availability, and business continuity. To learn more about Azure's data services, you can read Microsoft's documentation. Also watch for new Microsoft Azure courses on Cloud Academy, because we're always publishing new courses. Please give this course a rating, and if you have any questions or comments, please let us know. Thanks and keep on learning.